Okay, to start with, let's review for this big Chapter 4 test. And the very first day we learned about moving points, and I'll review that in a second. But then we got into this, which was proving that this is either odd or even. Do you remember on pictures how to tell if it's odd or even? Like here, is that one even or odd? That one's even because it has symmetry with that line running right down the middle. Does that ring a bell? Okay. Now, if you had a perfect ability to graph, you could just like graph that and look at it and go, oh, that's even, or no, that's not even, it's odd, or maybe it's neither one. How about this? This is close to odd. Is it an odd function? No, because it doesn't have symmetry over the origin. If I move it here, now it would be an odd function because it has symmetry over the origin. See what I'm doing there? It has symmetry across the origin. I'm going to do another one. And that's like, for instance, let's say, I curved that one, which is cheating, but I made it work. Let's say I had 2, 8 here. Do you get that that means that negative 2, 8 would be down here? Or negative 2, negative 8 would be down here? And why? Because when I put in a negative, I get the opposite. So here's the odd rule. I put in a negative, I should get the opposite of the y. That's why that works. Okay? But this is the odd proof rule, is that f of negative x will equal negative f of x. Now, the way I have you do it is by factoring out a negative 1. If you want to put a negative 1 f of x, that would be okay too, but I hope you get negative 1 f of x. It would be the same exact thing as negative f of x. All right, let's prove that x squared plus 2x is either odd or even or neither one. Do you remember we start with that and then we stick in, what was it again? Negative x. Go ahead and do that. Stick negative x in. And then the proof just keeps flowing down the page, and then the first thing you should check is whether it's even. So you stick negative x in, and you get negative x, and then you actually, this is one of the most important steps, you're just simplifying that down. Negative x squared becomes positive x squared, and positive 2 times negative x makes negative 2x. At this moment, you're supposed to stop and see if this is f of x. Because if it was, we could replace it and we'd say this. F of x is equal to f of x. But is this actually the same as that? No, it's not. And therefore, I now at that moment know and can say, therefore, it's not even, because that's not f of x over there. And now I keep going. Who remembers the next step? It's a really simple little thing to do. It's my favorite thing to solve math problems. Yes? Factor it. If you can factor it, you should. In this case, you can always factor out a negative 1 from something. You always can. But the question is whether or not what you have left will be f of x. When I take a negative 1 out of this, it becomes negative x squared. When I take a negative 1 out of that, it becomes positive 2x. Is this f of x? Is it exactly the same? No, it is not. And therefore, I can say this one was not odd, and therefore it's neither one. Let's do one that actually works out. F of x equals 4x to the third. I want you to prove that that's odd. Hint, start by sticking in negative x. I'll pause for a second while I give that a try. So you stick in negative x. 4, I stick in a negative x there. And now, dice of destiny, row 3, person 3. What do you say, sir? What do I do? Oh, I'm sorry. Thank you. Sorry. Row of 3, person 3. That's you, sir. I don't say names on the video, but ML?
Well, you would you multiply the you'd cube out the
Okay.
negative x.
All right.
Multiply the same as negative x.
So would you agree that this simplifies and still has a negative in it? So it's negative 4x to the third. All right, awesome. At that moment, if this had been the same as this, what would we have been proving? That it was even. So at that moment, I can say it's not even, because that's not the same. Therefore, not even. If it had been, I would have replaced it with f of x right there. If it's not even, you just have one more step, sir. Do you remember what to do? I'll keep it with the same person. Excellent. And then I have what left? Excellent. And then there's the final step. Negative 1, what? F of x, because that's f of x. And if you can end with a proof statement like that, ooh, that's the one that proves odd. You can say, therefore, odd. Scroll that up a little bit. All right, let's do one more that's even. All right, I'd like you to prove to me that that's even. I'll pause while you give that a try. Okay, let's see, Dice of Destiny. We are calling on row 4, person 3. What do you think? Plug in negative x. You are correct so far. 8, empty spot, put in a negative x. And now the most important one. You simplify it down. What did you get? And at that moment, you need to know what to do. If you just say right here that it is even, I mark it wrong. Why? Because you haven't written the proof. Here's the proof. That proves that it's even. You have to have this statement or the other statement to prove that they're either even or odd. So since this is the same as this, I can swap it in, and therefore I have proven. Therefore, it's even. How many of you think you can do that? Okay, excellent. Now let's talk about moving points. I got this graph, and it looks like that, and it's got some key points here, and I decided to take one of those points and move it according to this function rule. Let's take this point right here. Let's say it's at 1, 5. I want you to tell me where it would move to based on that function rule. Hint, stuff on the inside is your x stuff, and you don't trust it. Both the order and the operation. If it says times 3, you're not going to times by 3. I'll pause while you try that one. Okay, let's see if you did that one right. Did you start with x being 1, you go over here, and then you got a choice to make. You know, hopefully, that you're not going to multiply by 3, you're going to divide by 3. But should you do that first? Okay, do you get that in this little equation, there's a multiply by 3 and there's a subtract 1. What normally comes first is multiply by 3. So you don't do that first. You start by subtracting 1 first. Or do I subtract 1? You actually add 1. Okay? So this is definitely twisty-turny. All right, so I take this 1 and I go, instead of multiplying by 3 first, I'd start with that, and I don't subtract 1, I add 1. So 1 plus 1 makes 2, and then I don't times by 3. I could say I times by 1/3, or I could say I divide by 3. Final answer is 2/3. All right, so that was 2/3, comma, and then my y is much easier, because you can trust the stuff on the outside. It seems like you multiply by 2 first, and you do. 5 times 2 is 10, plus the 4 is 14. 2/3, comma, 14. All right, I know I got a lot of you on that one because of the order thing. I'm going to do one more similar. Let's try this. Let's say the point in question is 3 comma 4, and I want to move it to a new point based on this function rule. Negative 3 f of 2x minus 3 plus 1. Figure out where this point would go to based on those function rules. I'm going to pause and give that a shot. Okay, you take your x. You start by saying, should I do the times 2 or the minus 3? I should do the minus 3. And then the minus 3 changes to a plus 3. So I'm going to take 3 plus 3 is 6. And I'm not going to times by 2. I'm going to divide by 2. 6 divided by 2, final answer. Did you get 3? All right. Yes, it's possible for this point to do all of those things, but end up in the back in the same spot. All right, next is the outside. This y does this outside stuff. Seems like times by negative 3, so it is times by negative 3. That makes negative 12. And then it seems like I'd add 1, so I do add 1. And negative 12 plus 1 makes negative 11. Raise your hand if you had that one right. Almost everybody this time. Excellent. Okay, good. Any questions? You're like, I don't get how you just did that. All right, then, next topic we came to was what about, you know what, I'm going to pause for a second. If we have a function, let's make it go like that. Do you remember the whole local minimums, local maxes, absolute min, absolute maxes, domain, range, all that kind of stuff? All right, I'm going to say this point right here is kind of important. Let's say it's at negative 4 comma 3. I'm going to say this point seems kind of important. I'm going to say it's at like 6 comma 5. I'm going to say that spot's probably important for all this. So let's say that that's at 8 comma 0. All right. Here's a whole bunch of things you would be expected to know. Where is this? Oh, wait, I know I need one more spot. This spot's important. Let's say that's at negative 2 comma negative 2. Okay. I'd like you to tell me the local min, local max, absolute min, absolute max. Tell me one interval where it's increasing. Tell me one where it's decreasing. Tell me its domain. Tell me its range. And tell me, what does it mean when I ask you what's f of 6? And then what does it mean if I say what's f of x is 5? Like, what in the heck am I asking? Figure out those two answers. And last of all, tell me a 0 of this function. There's more than one 0, but just tell me a 0 of this function. All right, I'll pause for a second while you wade through those many little topics. They're all easy, but there's a lot of them. I'll pause. Okay, I'm going to hit a few of them, and then I'm going to pause again. For a local min, I'm hoping you saw that this was a local min. Now some of you are like, no, it's the absolute min. No, it's both. It's a low spot, and it's the lowest of all the spots I showed you anyway on this function. So that it is also the absolute min. Do you get if this line had continued on down like there, then it wouldn't have been the absolute min? There would have been no absolute min if the line had continued down, because then we don't know where it would stop. There's low spots all over the place, so they keep getting lower and lower. So anyway, it did not do that, so we don't have to worry too much about that. But if it had, I just want to make sure you knew what to do. All right. Then local max, that's a local max. This also is a high spot locally. Now, it might actually, don't worry about this, but maybe you would have to have it come down a little bit for it to be a local max, because it's kind of stopped. It doesn't have low spots on both sides of it. So I'm not actually sure about that one, but don't worry. If I'm not sure about it, I can't test you on it either. But I would have called it a local max, but I could be off just a smidge on that one. All right, next up is absolute min was this guy, and absolute max, the highest it ever was, that was this guy. He's not only a local max, he's also the absolute max. Yes?
So for the local min, local max, we have to list the absolute as well?
Nope. Well, yes. Sorry. The absolute maxes are both things. Yes. So if, for instance, this spot is the absolute max, it's not only an absolute max, it's also a local max. Yes. All right, next up is increasing. This was increasing really only in one little zone, but how do you say in here? You say it by saying the x value, so it's from -2 to 6. I'm curious how many of you had the gut feeling to know that was it. All right, so a bunch of you didn't know that. Maybe you should take good notes on this part. All right, you writing this down? Good. Next up is decreasing the little zone. There's actually 2 of them you could have picked from. I didn't. If I asked for all the decreasing zones, you'd have to put all of them, but it definitely decreases from here to here. It's the x's of it, so it's -4 to -2. If you chose this one, you would have said from 6 to 8 it was decreasing. That would have also been a good answer. Yes? I am okay with you using brackets or parentheses. I really don't care. I will use parentheses because, in theory, at the very end, when it stops, it's not decreasing anymore because it stopped right there. So I like to use parentheses, but I would accept you. Question? Yes? I would accept that as a local min, even though I could possibly be off on my definition of that. I just, yeah. It's not worth going and looking up right now because we have so many topics to review. So I would accept that as a local min. I know it'd be kind of a trick question if I tried to burn you on that. All right. And domain and range. You get the domain is like from here to here. How far does this thing go in this way? And those are the x numbers. And so it's from -4 to 8 was your domain. And did it touch at those spots? Yes, this should be brackets for sure because it touched at -4 and it touched at 8. That was from here to here. Then the range, how low to how high? The lowest it goes is -2 down here, and it's the range is about the y's. So it's this number to what's the highest it went. It did not go to 6. It went to 5. The y values over what the ranges are about. So -2 to 5. And it touched at both. Next up, f of 6. F of 6 is saying, hey, buddy, x is 6. Tell me what y is. Well, if x is 6, that was this point right here. So 6 comma 5. And this one's saying, hey, I'm telling you that f of x, which is like y is 5. And I want to know what x is. And that's the same spot. It's right here. That's where y is 5. So the x would be 6. And last of all, I asked about a 0. Do you get there was actually 3 spots where this function had a 0? There, and there, and there were all zeros. Only one of them was labeled, so I'm going to say 8 comma 0. But this one's pretty obvious. That one's 0 comma 0. And I didn't even tell you what that one was, so you'd had to make up some number for that. But I just said to give me one of them. So did you say 0, 0 or 8, 0? That's what the zeros are. They're the x-intercepts. Okay, that covered a ton of stuff. Now, that leads us to this kind. We practiced this yesterday. Say you had this one. That's f of x. I'd like you to figure out for me. I purposely didn't make that symmetrical, okay? So I'd like you to figure out for me, wait, this one of these isn't really going to work well. So I'm going to extend this a little further and go like that. Okay, I want you to tell me what is f of x with bars around the outside, what is f of x with bars around the inside, And lastly, what is 1 over f of x? That is totally different. I would want to do that on a different graph if I were you. Okay, first things first. This one's first. Dice of Destiny, who's going to explain that one to me? Row 6, third person. Can you tell me what to do when you have bars around the outside? The negative y's, which are in this neighborhood right here, what do you do with them? Reflect them up over the x-axis. Excellent. So this part right here goes up instead of down, and then it continues. That part all stays part of my answer. The blue one would be it. Raise your hand if you had that one right. Okay, good. The second one, where you're absolute valuing the inside. That is row 2, person 4, CB. Go ahead. Take the x's that are negative, which will be this little zone right here, and what should I do to them? No. Okay, at least you knew they were important. Because the negative x's are getting absolute value, they're important. What happens to them? Anybody know? They just get erased. They get destroyed. They're gone. And I know it seems like they should get just reflected over here, but they do not. All right? So they're gone. Why? Because now when you put in a negative x into this function, like let's say a negative 3, then the function won't see it that it's even negative because it'll absolute value it, and it'll only give out the answers that were from the positive x side. So it can only see answers like this because all the negatives are going to get absolute valued away. So then, to finish the answer, it's not just this part, then this part, which I tried to make it offset a little bit so that you could sort of get an M sort of a feeling out of it. There, the golden arches, except they're blue. Raise your hand if you had that one right. Good. And then the last kind, I'm going to give you a little bit more time to do 1 over f of x. And be careful in this little zone right here. I'll pause while you finish that. 1 over f of x. That's called the reciprocal function. Row 1, person 2. Hello. Tell me what's an important spot when I'm doing this reciprocal function thing. X equals 0. Why is that so important? These spots. All right. And technically, I realize I said x equals 0. It's actually where y equals 0, right? The x-intercepts are where y equals 0. And that also makes sense because the y here is on the bottom. And so when the y is 0, it's a big deal because then it's 1 over 0. So you need asymptotes there and there. How many you had the asymptotes in the right spot? Good. Next up, another important spot. Row 1, person 3. Another important spot on this graph. Hint, it's the only spot where they both, the original and the other one, are the same. Then you're learning something. I know you were gone for a day. Probably didn't get the video yet. This is I'm going to call that where it's 1. I don't know where 1 is, but I'm going to say that that's 1 on the y-axis. So then, why is that important? Because when y is 1, 1 over 1 is still 1. Those are the two spots here and here that the new function and the old function would share. And then as this gets to be its highest, the inverse will be at its lowest. So that's like this. And then as your original function gets really small, this one gets really big and also really big. And also you can just know that they're going to get attracted to the asymptote lines Kind of like a moth drawn to the flame. Or in our case, we don't have many open flames nowadays. The moth drawn to the light on your front steps. Okay. So, I told you to watch out for this area, though. Remember that? How do we do the inverse of that little area? All right, well, in that little zone, it's hard to tell because it's almost vertical there, but it's at its highest, relatively speaking. You know, it's going down right there. So the inverse, which I did in blue, so I'll do in blue again, will be at its lowest. Let me remove this little circle so I can zoom in on that area better. It'll be at its lowest right there. And then as I move from left to right, it's getting smaller and smaller on the original, so this needs to get bigger and bigger. So again, it'll approach the asymptote line in that little tiny zone. I'm going to zoom in on that zone closer for you. Okay, so it was the bottom part of the original function like this, right? And if I zoom in on this part right here, as here's the asymptote line. We'd all agree where it crossed was a big deal, right? And then when this part of the original was at its highest, the inverse would have to be at its lowest, because it's 1 over whatever that was. And then as your original function got really small, the other one would get really big. And then I can't tell whether or not it hit 1 or not. If it happened to hit 1, that'd be pretty handy. Because if it hit 1, like right there, which is what we would probably do on a test because 1s are so important, let's say that that's 1 right there, or in this case -1, then it would have to touch right there and get closer and closer to the asymptote line. Why is it going away? Because as this is getting really small, so this has to get relatively really big, to therefore heading downwards. All right, that's the toughest kind. I understand some of you are going to agonize over that on the test. Do you get, if you have to, you can do it point by point? If I zero in on a point in here and say, okay, I'm going to pick a spot that's right there, and I'm going to say that it's at -7, comma 1/2. Do you get I can just take that point and then do the reciprocal of it? Okay. To do the reciprocal of that point, do you get when it's 1 over f of x, I'm really just taking 1 over the y value of the point, right? So then I could take 1 over the y value of this point. It's a relatively small spot at 1/2 is its height. So its new location would be 1 over that. 1 over 1/2, which gives me 2. And that means I go -7 out, and then I go down 2, and it's like down here. Yes? Kind of, yes. I prefer, because not every graph can be flipped over, okay? And also, I don't want you to think it's a reflection, because it's certainly not down there, right? So here's the process. You find the 2 spots where it hits. Asymptote, I need to make dotted lines. Asymptote, asymptote. Then you find where it hits 1 and -1. And then you think through where the original was highest, the other function will be at its lowest. Okay? And so then I can kind of go, okay, it must be like that. And then when this gets really small, that gets really big. As this gets really small, that gets really big. And if you have to, do it point by point. So like this spot right here, let's say that seems like an important spot. Let's say it's at like, I don't know, 3, 7. Then remember, it's 1 over f of x. The y's are getting flipped. This would be 3. The new spot here would be 3, 1/7. And so it would be really small, really down low. Okay. Well, I'm glad there's some parts in here that make you squint and like go, ooh, how does that work? Because this is honors pre-calc. It's not supposed to be super easy. All right. Test is on Monday. I am here Monday mornings, coincidentally. Have a great day.